Hey everybody, this is Horner and welcome to week 2. In week 2, you'll want to scroll down to week 2 in the lessons area of the Blackboard page. And once you click on that, it'll give you the objectives, which you can read. And then it's going to talk a little bit about the experimental design template as well as the AP Physics Inquiry Lab template. And then there's a little Hooke's Law lab here. So I just want to show you a couple things. The template can be downloaded here, so if you click on that, it will download the template. You'll be able to see it. For the next part, there is a video that goes through what this D squared acronym stands for and the best way to use it. So you'll see that as it comes up. The next thing that is on here is the AP Physics Lab Inquiry template or Inquiry Lab template. It's an excellent resource. It does use the D squared template. So if you watch this video and have the experimental design up, you'll kind of see how that works. And then if you open this document up, there is another video that goes through how to use this effectively with your students. So it is this video, Experimental Design Template, and you can go ahead and watch both of those. Hopefully those are helpful. The task that we have for you this week is to then complete the Hooke's Law lab with the attached or the associated free response question. The Hooke's Law lab is a copy document here, so when you go in, you'll just say make a copy. It'll take a little while and then it'll finally come up. And it is a Hooke's Law lab. If you read the description that we have back here, you'll be able to kind of see that it is designed with the 4.2 and the 5.1 science practices in mind. So that's a super important thing for you to know. The lab goes through, you'll be able to kind of see what the lab covers and how it works. There is the virtual simulation, which is a PhET simulation. So you just go ahead and open it. It's one of the new HTML5 and it works really well. The best thing to do is go over and grab the one that says lab and start it. And you'll be able to hang masses from here. You can change the actual mass on it. It's going to bob up and down a bunch, so best thing to do is put lots of damping on it, and then that way it won't bob up and down, but it's pretty easy to increase and decrease the mass on that. Then you can change the amplitude, kind of figure out, about how much spring there is there, how springy it is. A ruler to measure that displacement. You can take it off, kind of find out where it starts, and then put it on and find out how much it stretches. So that's really important. If you are doing simple harmonic motion with this at a later time, then you definitely want to make sure that you turn that dampening down and give it no dampening so that you can really kind of see what's going on. You can also do this one in slow motion, which is nice because then when it gets down the bottom and you can stop it, you can figure out kind of what's going on. They also have a height here of 0, so you can figure out how high it is. Just all kinds of really cool things that you can do with this. I would download and print this because now it does tell you exactly what to do. There's animated GIFs here that show you everything that you need and takes you step by step on what to do. You'll probably want to print the part from here on down. You will have to include the spring number, all the variables here. You have to do a little bit of math, and then you'll want to plot your best fit line, go through, find the slope, do those type of things. Then we always use percent difference. We don't use percent error because these are also measured values, and so we're going to use percent difference instead of percent error. The next part of this is the important part. This is what they would see on the AP exam, and so it talks about how they would go through and really kind of tell us how they would do this. I always find it really nice to be able to have the kids do some sort of cookbooky type lab and then do an inquiry lab that's very, very, very similar, but still has some things that are a little bit different. So you'll see how this question is different. There's an A, there is a B, there is a C where they sketch. So there's no data to plot, but they are going to sketch a graph. And then for letter D, they'll just ask them a simple question that they could go through and answer. You could make this a paragraph length response if you wanted to. When you are done, you can either use, there's a great program called Kami out there that you could use to fill this out. And I think I've put that in this part. you'll be able to go through and fill it out and then take a picture of it, and you're going to upload your pictures. Either that, or you can submit, maybe if you write on the Google Doc, you can do that, or if you annotate it using Kami. When you click on this link, it will take you in, and you'll want to attach a file. So don't just write on the text here. Don't put it in the comments. Instead, go ahead and upload it. This is very similar to what they had to do on the 2019 AP Physics exam, because everybody had to upload, or and you could take a picture and upload, or you could do it digitally and upload that. So that was kind of the trouble that kids had. So this is an assignment just so you can kind of see what that was like for them. And then when you have uploaded that, we'd love for you to do that sometime before Sunday night. And that would be just awesome if you could do that. We can give you some feedback then in week 3. We will have a week 2 facilitated session. That'll be on Wednesday at 7 Eastern, 6 Central, 5 Mountain, and 4 Pacific time. We'd love to have you come through. Anthony's going to go through some more of this, give you some extensions, some ideas, and so there are tips and tricks for just kind of taking a look at how we can really best implement virtual labs and those type of things. So we'll build on what we did in week 1. There's a really quick progress check, and then when you're done, you can click to go to week 3. We don't have week 3 ready for you yet. We want to make sure that week 2 goes okay, and then we will move on. So that is what we are doing this week. Hopefully that's helpful, and hopefully you're having a great week. All right, we will see you all on Wednesday. Thank you so much.